So before we actually talk about geometric sequences, these aren't in your notes. What do you remember about an arithmetic sequence? Nothing. Can anybody give me an example of an arithmetic sequence? Still nothing? Sucks. Okay, I'll give you an example of an arithmetic sequence. 5, 8, 11. Why is that arithmetic? Because you're adding 3. It has a difference of 3. Does anybody remember the rule for an arithmetic sequence? Starts off with ace of n is? Where did K come from? D for difference. That was arithmetic. Those actually required, once you plug stuff in, do a little bit of work. Okay, that was the arithmetic sequence. Anybody remember how you find the sum? Sum of n things for arithmetic? It's been on like 10 basis points. That's past stuff, kids. Okay, I just want to remind you it's still there. Today is geometric. So arithmetic moved from term to term through either adding or, if it was a negative, difference subtraction. What do you think geometric does? If arithmetic is adding and subtracting, make a guess. What's geometric? There you go, multiplication. Or its inverse, division. What was cold? There's 3 sequences up there, and the whole point of those sequences being there is just see if we can figure out the ratio or not. You know, I feel like everybody ought to know the ratio of 20, 60, 180. I could be wrong about that. The number is 20, 60, 180. What's the ratio? Harley-mouthed 3. Because as you move from term to term, what are you multiplying by? 3. Now, if for some reason you can't do that, you're going to have to fall back on this. R is second over first, or third over second, and so forth. You just pick any 2 successive values, and you do division. That's all you do. The ratio could be 180 over 60. You might have to push the buttons in a TI-84, I don't know. But you could do that. How about in the second sequence, 1, 1/3, 1/9, 1/27? One-third is right. If for some reason you got to push buttons on that one, if you pick any 2, make sure you wrap or use the fraction key. If you don't use the fraction key, you got to do 1/27 divided by parentheses 1 divided by 9. Use the fraction key, you don't. You have to hit math frac, math frac, math frac. Yeah, so you do that. How about in the last sequence? 3 halves. You're going from a 3 to a 9 to a 27, that's multiplication of 3. And at the bottom, you're going 4, 8, 16. There's your ratio, 3 halves. And again, if you're not capable of doing that, you can push buttons on a calculator. can. All right, there's how you find R. What's on the next page is probably how you write a rule. Anybody know this one already? Rule for geometric sequence. Been asking these all day, hoping you can spend some time studying over the weekend for a formula quiz, but apparently you didn't. No? Good thing I moved your formula quiz to Wednesday. The nth term is the first term, a sub 1, parentheses, r, exponent of n minus 1. The nice thing about these is, unlike with the arithmetic rule, you don't have to do any work after you plug in. Nothing. You just plug in, this thing is done. Unless you had to find pieces. So there's some text given. It says, it's supposed to say write a rule for the nth term of a geometric sequence with the first term of 4 and a common ratio of 2. So if you can read that text, what's a sub 1? 4. And what's the R ratio? 2. And then it's simple, plug in. The nth term is a 4, parentheses, 2 to the n minus 1. And with that rule, you can find any piece. If you wanted the 35th piece, what would you plug into it? 35, that's right. You know why your notes, last week your notes were 7.1.7.2. Then they jumped to 12.3, 12.4. You know why they did that? Because I used to teach this separately. That function right there, 4 times 2 to the n minus 1. What kind of function is that? What were we talking about last week? We were talking about exponential growth and exponential decay. That function right there, if you were to create a string of numbers from it, if you plugged in a 1, you'd get a 4. If you plugged in a 2, you'd get an 8. If you plugged in another 3, you'd get a 16, 32. What's happening to it? It's growing how? Exponentially. That is exponential growth. That's why this stuff is here. I decided to move it into the exponential growth ones, because it is. Guess what would it look like if you graphed it? If it's exponential growth, how would it start? Starts flat, and that's right, there's exponential growth functions. All right, write a rule for the nth term, then find a sub 12. All right, so what is the form you're going to plug into? It's geometric. What's the form you're going to plug into? A sub n is what? God, y'all are quiet today. What did you just write down? Keep writing it until you know it. A sub 1 what? Pick out your pieces. So you've got a sequence in front of you. Reasia, what's a sub 1? Yes, ma'am. Alex, what's the ratio? -1/2 is right. I know not everybody sees that. Take a -76, you divide it by 152, and you get a -1/2. Now we have all our pieces. A sub n is what? Anybody? So tired of talking to myself all day. Milo, what's a sub 1? 152. Parker, what's going to be in parentheses? -1/2. And what's the exponent? N minus 1. Now the goal here is to find the 12th term, right? Plug 12 in. Make sure you can push buttons right too. Find a sub 12, you let n be 12. If you don't know what 12 minus 1 is, no one cares, because you can literally type that in a calculator. And you should do this, because we're not going to return a decimal. I'll return a decimal if you have to. 152, -1/2, rooftop, 12 minus 1. sometimes you do these things, you get funky little decimals. For a lot of them, though, your calculator can still convert it to a fraction. So we can do this one. How do you convert it into a fraction? Math, and then enter, enter. Math, enter, enter. Negative 19/256. You know, on the EOC, if you go blank, something you can do is you can kind of do this by hand in essence. You'll still have to figure out how to write the rule, but you can find the 12th term pretty easy. Once you figured out you were multiplying by a negative half, you could have written out 12 terms, couldn't you? Might take you a while. Take a negative 19, you multiply by a negative 1/2, what do you have? No, you have positive 19 over a 2. We're not going to use decimals. Now you multiply by a negative half again. What do you have? What's negative 1 times positive 19? What's the bottom going to be? 4. Look what's happening at the top. Negative, positive, negative, positive, negative, positive, negative. What's happening at the bottom? It's just doubling. You could just write this thing out. Wouldn't take you that long. I got 2 more renditions to get to that negative 19 over 256. You could literally just write out 12 pieces of it. It wouldn't take you that long. Of course, you like your decimals. Whatever with decimals. All right, write a rule given a term and a common ratio. This one's a lot easier than some of the ones in your homework, but if you do the homework, I'll show you how to do the harder ones. One term of a geometric sequence is that the 6th term is negative 96 with a common ratio of r equal to 2. Write a general rule. What's your form for your general rule? How do you act? What is the general rule? A sub n is what? You need 2 things. You need the first term and you need r, right? You need a sub 1 and you need r. What don't you have? First time I ever saw stuff like this was at a math contest. We've never been taught any of this. But I don't remember if it was a sub 10, a sub 12, whatever. But I remember what I did. I figured I needed however many blanks there were for the number. This is a sub 6. I need 6 blanks. Make sense? What's in the 6th blank? Negative 96. I'm pretty sure you could tell me the 7th and 8th term is pretty easy. But I still want to write the rule. If I was going to move right, what would I multiply by? 2. But to find the first term, I've got to move left. So what do I have to do? All right, so you might want that little note in there, I don't know. To move right, multiply by 2. To move left, divide by 2. Lexi, you having a hard time seeing or reading? Yeah, you missed about 3 months of interpreting my handwriting. It's better than some of y'all's. Usually not a female, but most males. Men just have bad handwriting in general. So anyways, let's move left for a little bit. What precedes that negative 96? Negative 48. Addition and division. Hopefully you're doing it in your head. What precedes a negative 48? Negative 12, negative 6, negative 3. Now you have everything you need for your rule, don't you? You do. What is the rule for this sequence?
A sub n equals -3, 2, and then to the n minus.
N minus 1. Now, again, as small as this thing is, I'm not even going to use that rule. That was just so I could come up with a rule, okay? If I was your age and I had written down 6 things and wanted the 8th, I would just keep doing what I've been doing. Does that make any sense? Now, if it asked me for a sub 40, I'd plug a 40 in, right? Round 2 away from the answer. What's the 7th term?
-1,
Negative 192. And what's the last term that we care about? Negative 384. So I was just continuing on from above. And I wanted that guy right there, negative 384. But you need to pay attention. Like if it says to go out 50 positions, don't even try to draw 50 blanks. You'll probably miscount it. I mean that. I bet you'll miscount it. Try it one day. Try to draw 50 blanks on a piece of paper. Bet you do 49 or 51. It always happens. If it's short though, just do it with the easiest way you can. And that's it for sequences. So now you're moving on to sums or series. Here's another formula given to you by Gauss, the same guy who gave you all that stuff we talked about in the beginning. Find the sum of of a finite. You know what finite means? Stops. Finite means limited or stops. Sequence that stops. Now they say we only have a finite resource of oil. Do we have an infinite supply of oil on this planet? Yeah, that's what they say. They're finding out it doesn't take tens of thousands of millions of years to create oil. Sometimes it only takes 10 or 20. A lot of things that they assume that are actually not true that they're finding out. Anybody know this formula? Fudge again. Sum of n things when you're dealing with a geometric sequence is a sub 1, big old set of parentheses. 1 minus, I'm going to put this r in its own set of parentheses to the n over 1 minus r. It's not that way on the form for this, but it should be. It's a big deal if your ratio is negative. Not a big deal if your ratio is positive. A sub 1 is what it's always been. What's a sub 1? That you care about. You know what r is. You should be able to figure out n. Here's some new notation. I don't know if I actually use it with you or not, but I want you to see it once in your life. That big, funky Greek letter. Anybody know what it is? No. That's the uppercase Greek letter sigma. We use the Greek letter sigma just because it looks nice as an operator. And sigma starts with an S. Now what are we trying to find here? Sums, right? Last night yet, sums also start with the letter S. So that's why they adopted using sigma. So that funky notation there means to find the sum of the first through 8th terms of the sequence, 4 times the negative 3 to the n minus 1. That's all it means. The long way of doing this would literally be to find a sub 1, a sub 2, a sub 3, ... all the way to a sub 8 and add them together. If you want to find a sub 1, you plug in a 1, right? A sub 2, you plug in a 2, and so forth. And then just add them all together. It's doable. But you got a perfectly good formula for this. But by the way, you actually don't have to plug anything in to find a sub 1. That right there is in the form of a sub 1 r to the n minus 1. It's already in the form you're supposed to know and understand. Or at least somewhat understand at this point in time. If it's in that form, what's the first term? 4. What's the ratio? 3. You have everything you need, don't you? Well, you need to have 2, don't you? First through 8th term. How many terms are there? No. It's high minus low. Add 1 back. Just 8. Use your fingers. 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th. Isn't that how I did it the first day we talked about all this stuff? We used our fingers. I use my fingers.
I didn't want to 8.
I know what you did. 8 of them. So everywhere I see an N, I'm an 8. I encounter an ace of 1. What's she? 4. Tall set of parentheses. 1 minus what?
-3.
What power?
To the 8th.
8th over 1 minus? -3. Anything wrong with what I wrote? What happens if you take a negative number and raise it to an even power like 8? What is it supposed to be?
Absolutely. No.
If you take a negative and raise it to an even power, what's it going to end up being? Positive. If you type this in the way it's written, you'll get the wrong answer. That's why I put parentheses up there. It's a big deal. You can have everything right except for the set of parentheses and you miss the whole problem. And you should type that in and see what you get, and you should play along. And you didn't play along on the last one. You should play along on this one for sure. There's a 4, then there's a parentheses. How do you pull up that fraction bar?
Math and
Right, that's how you feel.
you go up with, up 1.
Hit math, which is right underneath that green key. Scrolling right to num.
You go up 1.
Hold on, give Andy a minute. Are you here yet, Andy? You got 4 parentheses in your math num. What do you got?
I don't remember.
Are you doing your own thing?
No, I was trying.
Equation solver. 4 parentheses. Math. No. Right. Press that up arrow.
The error when I write it.
You'll see you're highlighting N over D. That's numerator over denominator. That's a fraction key. Should look like that. Lexi, are you able to get this typed in?
No, I was not.
Parker, can you help her? You're right by her.
Yeah,
Oh, you don't have it yet?
It gave me a error. I don't know.
Okay, I'll go back to Lexi then. You don't have to close it off. If you type that in, you get it. Feel free to press enter after all that.
So there you go, I got it.
Just got that 4 parentheses.
Math.
It's supposed to be 1 minus -3.
Oh, I missed a sign, didn't I? Good thing I didn't press enter. It is 1 minus a -3. Press enter. -60. -65, 60. You don't have to press enter. Well, maybe you do. No, you can go back. So your problem is there's a minus key and then there's a negative. Different. Yeah. You see the negative and the minus sign? Keep that there. Should get -65, 60, and everything's said and done. That's just a formula, kids. Good enough. Find the sum of the first 5 terms of this series. Now, if you saw this on a test, would you even worry about a formula? Man, I hope you don't. What's the 4th term? What's the ratio, kids? The ratio is 3. So whatever's here is 3 times 27. I had something else stuck in my head, which is 81. And the 5th term would be 3 times 81, which is 243. If you see something like that on a test, don't you freak out about formulas. Those are ones you're not supposed to miss. Now, would you want to repeat that process for 30 terms? I wouldn't either, okay? Nobody should. Same series, but this time 30 terms. So again, what's your little formula? S of n terms, what is she? A sub 1 times Grace. Try and remember, sometimes you need to wrap that R in a set of parentheses. If it's negative, you have to wrap it. Positive, don't worry about it. All right, we're going to find the sum of 30 things, the sum of the first 30, right? 30 things, kids. Everywhere you see an N, you're 30. If you look at that series, what's the first term? 3. 1 minus, what was R again? 3. What's N going to be? 30 over 1 minus 3. And again, you can put this parentheses here if you want. It wouldn't kill you to always wrap that piece. Really wouldn't kill you to do that. Because I guess if you don't do it, sometimes you forget. And it's 3 parentheses math number up. One minus parentheses 3 rooftop to the 30th power over 1 minus 3. And press the magic enter key. That's what you get. You're more than welcome to hit math answer fraction. They ain't gonna do you really good. That's a huge freaking number. That's scientific notation, isn't it? I think you guys are going out 6 digits this year in scientific notation, aren't you? What's 6 significant figures of that number in scientific notation? Come on, everybody likes Miss Abbott more than me. What's 6 significant figures of that number?
8, 8, 3, 7.
Yeah. 3.08. I'm too tired to remember what you said. 837. And that E is the 10 times 10 to the 14th. Sometimes you run across people who don't like that. Some people don't like any decimals whatsoever. So they drop the decimal. If I drop that decimal and make it 308,837, what's the power on that 10? Be 9. You shifted the decimal to the right 5, so you had to think 14 minus 5 being 9. Scientific notation, kids. It's important in science. It's important in math, too, when you start talking about big, big numbers. Most of the stuff you do here is small stuff, not big stuff. And I think we're at your last slide. I don't think it's that hard. No, you got 2 more, don't you? This is the concept, and the last slide is the example. The concept here is finding the sum of an infinite series. So you have a string of numbers that go on forever, and you can find the sum of them. That sounds like some BS. It does, doesn't it? The sum of an infinite number of things. So long as the equation you're given is in this form right here, you can actually do this if the absolute value of R is less than 1. long as that ratio is less than 1, you can actually do this. The other day we did something like this. We did a 1, a half. I talked about it anyways. Quarter, eighth, 16th, 32nd. Goes on like that forever. Does it ever actually hit 0? No, but it gets so close to it, doesn't it? You get that like 1 over a quadrillion. You think your calculator could even tell you what that is as a fraction? It would literally tell you 0. It's not. That's as far as it can go. What happens is the series is what we call converges. It converges on 0. All that means is it gets really close. It's really close to a 0. If you care, I could actually show you the proof of why this formula works. But you'd have to do that one-on-one with me. I'm not going to try and teach a whole bunch of kids just a little bit of calculus where I can show you this thing is true. Converges. Converge on 0. Looks like a 6M, doesn't it?
Yeah.
It's a 0. No blank there. Formula for this is the sum of an infinite number of things. It's the first term over 1 minus r. You can find the sum of an infinite number of things with that itty-bitty formula. Quite amazing. You should be a little bit bothered by the idea of finding the sum of an infinite number of things. You should be a little bothered by that.
So that has to be infinite.
Huh?
But it has to be infinite.
No. The numbers are getting smaller. Wouldn't add to infinity. So you got 2 examples. It says up top, determine if the series converges. If so, determine its sum. First series you're given. Is it converging on a 0? No, it's growing. It's 164, 128, so forth. There is no way you could add up an infinite number of things here and get anything, is there? It just keeps growing and growing and growing and growing. This is called a divergent series. It literally diverges from 0. Need me to mansplain that for you? That means it gets farther away from 0. And the deal is we want to get closer. It is a divergent series. How about the next one? If you ignore the signs, just focus on the actual number. Are they getting smaller and smaller and smaller and smaller? That's the deal. It's a convergent series. What's R? That's right, it's negative 1/3. If you don't know that, you might have to push buttons in a TI-84. Take a ninth, divide it by negative 1/3, and you will get negative 1/3. That satisfies the rule. The deal was the absolute value of R was less than 1. Now you can do it. You're going to find the sum of an infinite number of things. What's the first term? Negative 1/3. Sitting pretty over. 1 minus negative 1/3. That math key, I don't expect y'all know how to do that in your head. I used to teach you how to do it by hand. But I don't anymore. Not enough kids could do it. Ta-da! Negative 1/4. That funny string of numbers, if you wrote them out for all of eternity, adds up exactly to negative 1/4. And that is your